So guys, let's go to the next model. That is the highest power of 7 which divides 81 factorial. So how to find this? So generally we say that 81 cannot be divided by 7, but 81 factorial, can it be divided by 7 or not? Yes, exactly. Why? Because 81 factorial consists of one multiple of 7 minimum, because it's a factorial, it's not just an integer, right? I hope you understand what is the difference between 81 factorial and just 81. Okay, 81 factorial is nothing but you have to multiply the numbers till 1 from 81. So 81 into 80 into 79 and so on up till 1. So in that we will come across 7 at least, right? That means 81 factorial is divided by 7. But they are asking highest power of 7 which divides 81 factorial. That means in these multiples you have to find 7 multiples, isn't it? That can be possible, or that can be found easily by knowing 81 divided by 7, the highest integer or the highest quotient that can divide 81 and 7. That means what is the highest multiple of 7 below 81? It is 77. That can be obtained by 11 as quotient. That means there are only 11 sevens, isn't it? Wrong, because we are going to see 49 also in this. That means there are 2 sevens in this 81 factorial. That means instead of 1 7, I'll get another 7. So how to find that? 81 divided by 7 square. Okay, with what is this function? This is integer function. Whenever you keep any number in this, it will give you the integer. For example, if I keep 2.3 in this square brackets, I will get 2 as the answer. Okay, that is integer function. So I am keeping 81 by 7 in this integer function first. That gave me 11 plus 81 divided by 7 square. That means 81 divided by 49. How many 49s are there, or 49 multiples are there below 81? There are only 1 49 in that. So I have to continue. Yes, I have to continue from this 81 divided by 7 cube plus 81 divided by 7 power 4. But for my dismay, it doesn't have any value, because these are integer functions. That integer will end up as zeros. Okay, so I got 11 plus 1, 12 sevens, or 7 power 12. That is the highest power of 7 that divides 81 factorial exactly. Okay, let's move to the next things in this model. Find the number of zeros in 6 factorial. Yes, obviously it is very easy for you guys to find how many zeros in 6 factorial. It will say, so 6 factorial is nothing but you can find directly value of 6 factorial, that is 720. So there is only 1 zero, right? But what if I give it as 56 factorial or 156 factorial or 4156 factorial? This will make sense, okay? Or this makes a problem very tougher. But even though the problem is very easy, how? You will find number of zeros. That means 6. How many fives? How many tens are there in that? Can I say how many tens are there in 6 factorial? No. Why? Because 6 factorial, 6 is less than 10. I cannot get a multiple of 10 in that. But wait, something is there in this. What is that? I have 1 5 and 1 2 to make 110. Not 110, a 10. Okay, so this gives me 1 0 in my 6 factorial or 5 factorial for that matter. Okay, so if I have 1 5 and 1 2, I'll get 1 0. So to find that, I have to divide. I have to know how many 5s are there in the factorial exactly. Or you may say that, sir, even though even 2 is needed to make a 10 or to produce a 0. So can we calculate number of 2's in 6 factorial? Yes, you can calculate, but every 2 will not make 0. It is only a 5 and a 2 will make a 0. But for our for our luck, we already got 2's in for every alternate number, because every even number has 1 2 in that. Okay, and every for every 4 numbers we got 4 square also, I mean 2 square also, that is 4. That means we can wait for every alternate number we get a 2. So that's why I'm not calculating how many 2's are there and how many 2 squares, that is 4's are there in the given factorial. So I'll calculate only 5's, number of 5's. So 6 by 5, highest integer function, that is 1, plus 6 by 5 square, that is 6 by 25, that is 0. So and so on, we will get zeros only. So it is only 1 5 which is there in the given factorial. That's why 1 5 with multiplication of 2 you'll get 1 0. Okay, so I hope you got this one. Let's see another problem in the same thing. Find the maximum value of n such that 157 factorial is perfectly divisible by 10 power n. Now they are clearly asking perfectly divisible by 10 power n. That means I have to see 157 divided not only by this 10. If I go on finding like this, I'll get a wrong answer. Why? Because 10 is nothing but a 5 multiple, right? So I can, instead of 10, I can take 5 only here. Okay, so finding with 10 is a wrong thing. So finding with 5 is the right way to find the number of, highest value of 10 power n. So 157 divided by 5 square plus 157 divided by 5 cube and so on, but 5 power 4 it will cross 157, so I'm stopping here. Okay, so 157 divided by 5, it is 31 times, and 5 square 25, so it is 6. Here only 1. So total 38 5's are there in the given thing. 38 5's will come out of 157 factorial. So 38 5's, when they include with 2's, they'll get 38 zeros. Okay, so for zeros to cancel, I can take 10 power 38. Okay, so n value, the maximum value of n possible is 38. What is the minimum value of n? That can be anything, like 10 power 0. We can divide with that also. Okay, so next question is the power of 30. What power of 30 will exactly divide 128 factors? So I am giving this problem as your work to comment here in the comment box. So the power of 30, that means they are asking both 3 and 10. The what power of 3 and 10 will exactly divide 128 factorial. You can take the highest power only. Okay, then they are not asking, they don't mean that the lowest power. So when they are asking the power of 30, that means they are asking the highest power only. So I hope you got this model. So now comment the answer, right answer in the comment box. Thank you.